Okay, well, first I want to start off by saying with this problem, this is 182, method 182 with 3.3, number 17, that the answer that the student got here is correct, in my opinion. I don't think it's my opinion. I think it's just a fact. And I'm really not sure why they went to this point for their answer at all. They're equivalent, I'll say that. And the big deal is, and I worked it out, that if you were to take, the 5, divide a 5 out of here and a 5 out of here, you end up with a natural log of, for example, 1 plus x over 5 minus times 5 minus natural log of 5 times 1 minus x over 5. And really what we have is an absolute value. And I'm tending to wonder if that's where the issue is that didn't do an absolute value bar here and here. That could be the problem. In fact, that might be what the issue is. I would have rearranged this part to match with this over here. I'm probably getting a little too far afield, but you end up with like a natural log of 5 plus natural log of 1 plus x over 5. Do absolute values. And then minus natural log of 5 minus natural log of 1 minus x over 5. So that these go away. So it becomes equivalent in the end. So that's some backstory stuff that you may or may not care about. But I'm going to do the problem now anyway, just for fun, because that's what this is, right? Okay. So this actually utilizes some partial fractions. And so depending on your preparation for Math 126 or 127, you may or may not have seen this. I know the next section, 3.4, talks about partial fractions. So I was kind of surprised this came up in this section. But if you have a basic understanding of partial fractions, then you're going to be okay with this. If you don't, then you're going to get a little crash course right now. So what we again have, kind of like on 16, is you have this 25 minus x squared dy dx equals 1. And I'll divide both sides by 25 minus x squared. So that's dy dx equals 1 over 25 minus x squared. And again, bring that dx over. And we end up with dy equals 1 over 25 minus x squared dx. So we have the integral dy, which becomes a y, equals integral 1 over 25 minus x squared dx. And I'm really curious if one of you want to email me if you did this a different way than partial fractions. Nothing that jumps out to me on this, so unless you use the table, which is very possible. And this does become the y, but this is the real question: how do we do this? Well, this does factor to become integral of, we have a difference of squares, 1 over 5 minus x times 5 plus x dx. So now it's a matter of breaking this into two different fractions. So here's your little mini crash course of partial fractions. So I'm just going to start here. And we're looking at this 1 over 5 minus x times 5 plus x equals, and the way you do a partial fraction, so these are both linear fractions, you would do a over one of them, 5 minus x, plus b over the other one, 5 plus x. And you're trying to find out what a and b would be. And so one way to do this one, the way I would do this, because it's a pretty simple one, And let me change my colors here. I'm going to go ahead and multiply both sides by 5 minus x times 5 plus x. So these cancel. So 5 minus x times 5 plus x. So these cancel. And then 5 minus x times 5 plus x. So these cancel. And you have 1 on the, oh, change colors. 1 on the left equals a times 5 plus x on the right. And then plus b times 5 minus x. So now you look at the two cases. You want to, this is again one way of doing it. You want to make, one way to do it is to make one of these factors 0. So if x equals 5, you have 1 equals a times 5 plus 5 plus b times 5 minus 5, excuse me. And so the second part is just 0. So that tells you that a times 10 equals 1. So a equals 1/10. And then if you say x equals negative 5, you have 1 equals a times 5 minus 5, or plus negative 5, whatever, plus b times 5 minus negative 5. And this first one is going to be 0. So you have 1 equals b times 10. So b equals 1/10. So this brings us to having this y equals the integral of 1 over 25 minus x squared dx, which is integral 1 over 5 minus x times 5 plus x dx, is now broken down into integral of 1 over 10 times 1 over 5 minus x dx plus, I'll separate the integrals, 1 over 10 times 1 over 5 plus x dx. And now these are pretty, I don't want to say simple because I don't want to sound rude about that, but they're really not bad integrals to evaluate because it's just gonna, you have a linear down below, so it just becomes a natural log. You just have to worry about the negative sign. So we end up with 1/10, and then this first one here we have, so it's a negative x, so it's going to be negative natural log of 5 minus x. And this negative here comes from this negative x here. It's like it's the derivative of the x is negative 1. And then we have plus 1 over 10 times natural log of 5 plus x. And so I just did the same thing here. Those are technically supposed to be absolute value bars. Okay. And then we have a plus c. Okay, this has been a lot of work to get to this point, right? And it tells us that we have the initial value problem. Y of 0 equals 8. So that means, this is our y, so that means y of 0 is going to be 1/10 times negative natural log of the absolute value of 5 minus 0 plus 1/10 natural log the absolute value of 5 plus 0 plus c equals 8. And I'm forgetting the parenthesis here. So we have, bring this through, negative 1/10 natural log of 5 plus 1/10 natural log of 5 plus c equals 8. These just subtract out then. So c equals 8. And go scroll down to the next page. y equals, and we could be, I'm not as good at this as some people. I don't always factor everything out or factor things. Yeah. So 1/10 times negative natural log of the absolute value of 5 minus x plus 1/10 natural log of the absolute value of 5 plus x plus 8. So I can clean that up a little bit. We can call this y equals 1/10 times, I'll put the positive one first, natural log of the absolute value of 5 plus x minus the natural log of the absolute value of 5 minus x plus 8. And that's pretty much what the student had. What is different is I did absolute values, and so that may have been what triggered the program, because if you look at the answer in the program, it had absolute values. And you could factor out, like I showed you, the 5, and factor out the 5 here. Being an absolute value allows you to factor out a negative 5, and then the absolute value takes away the negative, and so it looks like in the same order as what they had in the answer above. So 1/10 natural log absolute value 5 plus x minus natural log absolute value 5 minus x plus 8. So, and notice they put the positive one first, they have their negative, so it works out. If you have more questions about that, please let me know. If you have any other ideas that maybe you solved it differently, please let me know about that too. Okay, thank you.